Hello students, welcome back in the online class. In the previous class, we have completed the examples on Poisson distribution. Madam has already started with the normal and standard normal distributions. She will complete the normal and standard normal distribution. Today we are going to deal with the next distribution, that is chi-square distribution. Chi-square distribution is derived from the normal distribution. The square of a standard normal variate is known as chi-square variate with 1 degree of freedom. That is, if x is a normal variate with mean mu and standard deviation sigma, then z equal to mu minus sigma upon sigma is known as standard normal variate, and z square is a chi-square variate with 1 degree of freedom. If z1, z2, zn are n independent standard normal variates, then z1 square plus z2 square plus so on zn square follows a chi-square distribution with n degrees of freedom. Here degrees of freedom means the number of independent variables. Now we will see the definition of chi-square distribution. A continuous probability density function, that is f of chi-square equal to k into e raised to minus chi-square by 2 into chi-square raised to n by 2 minus 1, where 0 less than equal to chi-square less than infinity and n is greater than 0 is a chi-square distribution with n degrees of freedom, and chi-square is called chi-square variate with n degrees of freedom. Here k is a positive constant and which depends on n, that is degrees of freedom. Then we have features of chi-square distribution or properties of chi-square distribution. The first feature of chi-square distribution is n is the parameter of chi-square distribution. N, that is the degrees of freedom, and degrees of freedom is the parameter of chi-square distribution. Then second feature is the range of chi-square distribution is 0 to infinity. The range of chi-square distribution is 0 to infinity, that is 0 less than equal to chi-square less than infinity. Next property is, for a chi-square distribution, mean is equal to n, where n is degrees of freedom, variance equal to 2n, and standard deviation is equal to square root of 2n. The next feature is, for a chi-square distribution, mode is equal to n minus 2 for n greater than 2. Mode is equal to n minus 2 for n greater than 2, and mode equal to 0 for n less than equal to 2. If n is greater than 2, then mode is n minus 2, and if n is less than equal to 2, then mode is equal to 0. Next point is, chi-square distribution is positively skewed. We know that the range of chi-square distribution is 0 to infinity. So the chi-square distribution is positively skewed for n greater than 2. And it is positively skewed means beta 1 value is greater than 0. Beta 1 is a measure of skewness. The next property is, chi-square distribution is leptokurtic, that is beta 2 greater than 3, where beta 2 is a measure of kurtosis. So chi-square distribution is leptokurtic. Then the total area under the chi-square curve is equal to 1. The total area under the chi-square distribution curve is equal to 1. The next property is, when n tends to infinity, chi-square distribution tends to the standard normal distribution. When n is too large, that is n tends to infinity, chi-square distribution tends to standard normal distribution. So these are some properties of chi-square distribution. Properties or features of chi-square distribution. Now if we draw the chi-square distribution, then the chi-square distribution curve is like this. This is the chi-square probability curve. And you can observe here chi-square distribution is positively skewed because the range of chi-square distribution is 0 to infinity. It is 0 to infinity. So it is a positively skewed curve. Then we have the applications of chi-square distribution. There are three applications or uses of chi-square distribution. That is, to test whether a population has a given variance. To test whether a population has a given variance. Then the next application is to test goodness of fit of a theoretical distribution to an observed distribution. Since the sixth unit, that is statistical inference unit, is deleted, in that unit, in testing of hypothesis, we have one test, that is chi-square test of goodness of fit. So there this chi-square distribution is useful, but unfortunately that unit is deleted from the syllabus for this year. The next use of this chi-square distribution, use or application of chi-square distribution, is to test independence of attributes in 2 by 2 contingency table. Again, this part, all these three applications are required in statistical inference unit, but that unit is deleted due to this COVID pandemic situation this year. So these are the three applications or uses of chi-square distribution. Next class we are solving going to study the t distribution, but here we will solve some examples on chi-square distribution. The first example is, if z1 and z2 are two independent standard normal variates, then name the distribution of z1 square plus z2 square and find its mean. In the solution, we will write the given values. Given that z1 and z2 are the two independent standard normal variates, therefore the distribution of z1 square plus z2 square is a chi-square distribution with the 2 degrees of freedom, not 3, it is a 2 degrees of freedom. If we added 2 standard normal variates, square of standard normal variates, then the degrees of freedom is 2. And mean is equal to 2. Here parameter is 2, so mean is equal to 2. You please consider this mean is equal to n, which is equal to 2. Then we have the next question. For a chi-square variate with 9 degrees of freedom, find mean and standard deviation. Given here is n equal to 9, so mean equal to n equal to 9 and standard deviation is equal to square root of 2n, which is equal to square root of 2 into 9, that is square root of 18, and square root of 18 is 4.2426. Therefore standard deviation is equal to 4.2426. Then the next question is, what are the mean and variance of a chi-square variate with 11 degrees of freedom? The solution, the given here is n equal to 11. So mean equal to n equal to 11 and variance equal to 2n, that is 2 into 11. So variance equal to 22. The next question is, for a chi-square with 10 degrees of freedom, P probability of 0 less than equal to chi-square less than equal to 9.34, which is equal to 0.5. Find median and mode. So what is given here is n equal to 10 and P, that is 0 less than equal to chi-square less than 9.34, which is equal to 0.5. So here median is this 9.34 and mode equal to n minus 2. Here n is 10 minus 2. So 10 minus 2 is 8. So these are the examples on chi-square distribution. Let's see one more example on chi-square distribution. If variance of a chi-square variate is 14, what is its mean and mode? Here given is variance, that is 2n equal to 14 is given. Therefore n is equal to 14 divided by 2. 14 divided by 2 and 14 divided by 2 is 7. So mean equal to n and which is equal to 7. Therefore mode equal to n minus 2. n is 7. So 7 minus 2. So mode is equal to 5. So such type of examples on chi-square distribution will come in the exam for 2 marks each. Next class we will study the students' T distribution.